when I went to Cambridge, I started meditating, and I started having experiences more spontaneously, which I guess would be classed as out-of-body experiences. And that's just one. I don't normally talk about these experiences because most of my physics colleagues will think I'm crazy or merely suffering from delusions. But that's an example of why I take psychical phenomena seriously, because I've had experiences.
Keep watching to learn more. For early access to our videos and live stream events, sign up for our free weekly newsletter at newthinkingaloud.org. New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu.
Book 4 in the New Thinking Aloud dialogue series is Charles T. Tart, 70 Years of Exploring Consciousness and Parapsychology, now available on Amazon.
Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today I'm very happy to be initiating a series of conversations on consciousness and cosmology with Professor Bernard Carr, who is a professor of mathematics and astronomy at Queen Mary University of London. He received his doctorate at Trinity College, Cambridge, England, under the supervision of Stephen Hawking. In fact, he actually lived for a year in the Hawking household back in the early days of their relationship back in the 1970s. He is the co-author of the book Quantum Black Holes. He is also editor of the anthology Universe or Multiverse. In addition, he's the recipient of the Adams Prize in Mathematics. He is a former president of the Society for Psychical Research in England, and he is currently the president of the Scientific and Medical Network, an international organization largely devoted to consciousness research. This is an internet interview, and now I'll switch over to the internet video. Welcome, Bernard. It's a pleasure to be with you.
Thank you. It's a pleasure to be interviewed.
You have really an extraordinary career, having balanced your interests in Buddhism and psychical research and in higher mathematics, physics, astronomy, and cosmology. It's rather unusual to maintain a professional interest in all of these areas.
I suppose that's correct, but I also feel that it's very important to try and make connection between all those areas. That's to say, between mainstream science and psychical research, and also spirituality or religious studies. I feel a proper understanding of the world involves that one makes a bridge between those three areas. But of course, in practice, that is difficult, because if you're going to be a successful scientist, you sort of have to devote your full life to it. If you're going to be a successful psychical researcher, you have to devote your whole life to that. And if you're going to be a successful mystic, you've got to devote your whole life, or many lives, to that. But nevertheless, I sort of think I made a compromise that I felt that it was so important to link these things. I would be quite happy to be a less successful scientist and psychical researcher and mystic if it enabled me to connect them in some way.
I think you've done an admirable job of it along the way, and maybe it would be useful to start to introduce our viewers to you by beginning with your student days at Cambridge.
Yes, in fact, maybe I'll even go back a little bit earlier than that. When I was at school, when I was about 16, I suppose, and when I was at school, for various reasons, I misbehaved, and as a punishment, I was roomed. That's to say, I was confined to my room for a week apart from lessons, and so I had nothing to do in that period except read books. And I read 3 books, and these 3 books really determined the course of my life. The first book was called The ABC of Relativity, and this was a book about Einstein's theory of relativity by Bertrand Russell, and this got me interested in the nature of space and time and physics. The second was a book called An Experiment in Time by Dunn, J.W. Dunn, and that got me interested in the phenomena of precognition and again the nature of time and psychic ability. The third book I read was called The Third Eye by Lobsang Rampo, which was allegedly by some Tibetan lama who had sort of taken over the body of a Cornish fisherman when the Chinese invaded, and he was talking about all the experiences as a Buddhist lama and the mystical and the psychic experiences that involved. So those 3 books triggered my interest in, on the one hand, science, and then psychical research, and then religious experiences. And when I got to Cambridge as an undergraduate, I immediately joined 3 societies. There were lots of university societies, and I joined the Astronomy Society, and I joined the Society for Psychical Research, and I joined the Buddhist Society. So this was the natural progression, developing my interest in those 3 areas. In my professional studies, I was studying mathematics and physics, but when I finished my studies, I had to decide what career to pursue. And I was really toying between pursuing a career in cosmology, which was the area of physics I was interested in, and pursuing a career in parapsychology, which is what I was spending most of my time doing. Because as a member of the Cambridge University Society for Psychical Research, I was spending a lot of my time doing experiments and visiting mediums and things like that. And meanwhile, of course, I was also interested in Buddhism. I'd taken up meditation, and I was, as a member of the Buddhist Society, I become fascinated in that. But I realized I wasn't going to forge a career as a Buddhist. So really, I had to choose between a career in cosmology or parapsychology. I did spend a summer working with John Beloff in Edinburgh to see if I was interested in parapsychology, interested enough to do a PhD in the subject. In the end, I was persuaded that I should do my PhD in cosmology. There was a colleague and a friend, Professor Donald West, who was actually an eminent psychical researcher, and he advised me that there were no career prospects in parapsychology, which was true at the time. And he said I would do better for the field in the long run if I established myself in a respectable field, and then from a position of strength, so to speak, I could then advocate psychical research as a respectable field. So I chose to do a PhD in cosmology. I was very lucky because my supervisor was Professor Stephen Hawking. This was in 1972. He wasn't so famous then, at least in the public domain. He was already known to be a very brilliant physicist. In fact, my tutor told me that he was the most brilliant person in the department where I was going to do my PhD. But I must confess, I'd barely heard of him at the time. But this was before he was really famous. He was working with Stephen Hawking, who, of course, was one of the greatest minds of the century, really. It gave me a good start in life, in my professional field. And I happened to be working with Stephen at the time. He discovered Hawking radiation, which was one of the most important developments in really 20th century physics. So I was very lucky. So my career got off to a good start on account of that. But then the only trouble was that as a result of becoming a professional physicist, I soon found that my time was being taken up by the sort of activities a professional physicist has to do. So I was writing papers in cosmology. I then became a lecturer and had to give lectures and things like that. And so the amount of time I could spend on my other activities, psychical research and religious studies, if you like, became much more limited. Nevertheless, I always maintained my interest in psychical research and religions in the spare time, even though I didn't spend so much time on those topics. And that's why I've always managed to connect them. So I suppose most of my time in life has been spent on my career as a physicist and a cosmologist. And I suppose that's why I'm best known. But I've also spent a considerable fraction of my time in pursuing my interest in psychical research and religious or spiritual studies.
As I recall, it was in these early years that you also began having out-of-body experiences.
Well, one of the things that got me interested in psychical research, besides reading the book An Experiment with Time by J.W. Dunn, I read a book by Muldoon and Carrington about out-of-the-body experiences. And I got intrigued by that because I thought, well, my goodness, if my consciousness can leave my body and I can go to other places in the physical world, maybe even beyond the physical world, I realized that was a real challenge to the normal view of physics. It suggests there's some level of reality that goes beyond the normal physical world, or some way of exploring the physical world even that goes beyond the conventional means. So I became particularly interested in out-of-body experiences. I remember at the same time I was reading some novels by Dennis Wheatley, and his hero is called the Duke de Richelieu, and he was regularly going out onto the astral plane and getting into battles with the evil spirits and things like that. So I think those two things between them got me interested in out-of-body experiences, and I started, of course, trying to have out-of-body experiences. And again, this was still when I was still very young, 17, 18. And indeed, before long, I seemed to start having out-of-body experiences. I mean, this is when I was at home, and I would start finding myself waking up in the middle of the night in the sitting room, and then I would suddenly realize I was not in my physical body, but in some other body. But I must confess that got me rather scared. I was, although I was intrigued in these phenomena, at the same time, I found myself rather scared at finding myself outside my body. And of course, at that stage, I couldn't be sure whether it was all an illusion or whether I really was out of my body. But I was sufficiently worried that it might be a real experience to be scared by it. And so for a while, I stopped having these experiences. Indeed, I tried to stop having these experiences. Later on, though, when I went to Cambridge, I started meditating, and I started having experiences more spontaneously. Which I guess would be classed as out-of-body experiences. And that's just one. I don't normally talk about these experiences because most of my physics colleagues will think I'm crazy or merely suffering from delusions. But that's an example of why I take psychical phenomena seriously, because I've had experiences. And of course, you refer to out-of-body experiences, but of course, psychical research is much more general than that. And I think my interest in psychical research is partly triggered on an intellectual level by simply having read the literature and knowing that these phenomena seem to exist, and then trying to relate that to physics in some way, because I am a physicist. And so in some sense, my passion is to try and extend physics to accommodate these phenomena. But at the end of the day, it's also triggered by personal experience, because after all, most of my colleagues don't believe these experiences are even real. These phenomena are real. And so I would only have the motivation to try and relate physics to these phenomena if I believe the phenomena were real. And although I don't claim to have had, such a wide range of psychic experiences, I feel that I've experienced them enough to believe that they're real, and to believe there's another level of reality out there which needs to be connected with physics. And I think that's true of quite a lot of psychical researchers. Most of them, I think, their interest was triggered by having had an experience. So although, of course, one of the points of psychical research is that you're trying to study these phenomena from experimental perspective, you're trying to bring them into the laboratory. Ultimately, I think it's having had the experience, which is what triggers many people to have an interest in the subject. So you're trying to link experiment with experience.
Well, one of your special interests is to see if the hyperspace models of physics, which are pretty predominant now in string theory and related theories like that, might also have something to do with consciousness. And it would seem to me that having had out-of-body experiences would provoke an interest in whether hyperspace has anything to do with it.
Yes, well, I mean, first of all, let me say why, as a physicist, I really do want to accommodate, I want to expand physics to accommodate these phenomena. I mean, I am very passionate about physics because I've spent my professional life studying it. And I think it's an amazing triumph the way physics on both the macroscopic frontier and the microscopic frontier has expanded our awareness and our understanding of the physical universe. I mean, all the way from the smallest scale of subatomic physics, the so-called Planck scales, all the way up to the biggest scales of cosmology, the horizon scale. Physicists has now given us an understanding of all the different levels of structure in the universe and how everything connects. It's shown us how the various forces of nature link the microscopic and the macroscopic domains. And that's a great triumph. And nevertheless, what always intrigued me was that although physics claimed to be close to a theory of everything, and this wonderful unified picture in some sense is a testimony to that, it clearly wasn't a theory of everything. It clearly isn't a theory of everything because it doesn't actually account for consciousness and indeed the whole domain of mental experience. So it always seemed to me that there's the physics theory of everything is really not a theory of everything. It's just a theory of particle physics. And yet, why should one not expand physics to accommodate these other levels of experience? And when I say other levels of experiences, I'm not just talking about psychic experiences. I'm talking about normal mental experience. As I'm sure you know, there's a huge problem even accommodating normal mental experiences into science. And a lot of physicists would say, for example, that consciousness by its very nature is outside physics. And the reason for that is simply that physicists talk about the outside world. They have a third-person perspective of the world. Whereas when you're dealing with consciousness and mind, you're talking about a first-person perspective. So a lot of physicists simply say, well, consciousness may exist, mind may exist, but it's nothing to do with physics, because physics is only concerned with the third-person description, not the first-person experience. But I've always disagreed with that, and I don't see why, in principle, science shouldn't be expanded to accommodate experience. But then, and so even now, whereas consciousness used to be a rather taboo topic within physics, at least 20 years ago, physicists wouldn't really talk about consciousness. Now it's almost mainstream. I mean, a lot of physicists talk about consciousness because, of course, its connection with quantum theory and the way consciousness may collapse the wave function, for example, and the way in which, of course, developments in neuroscience and artificial intelligence, consciousness now is now seen as a respectable subject, even among physicists. So you have people like Penrose and Hameroff who sort of try to relate it to physics. So undoubtedly, part of the link between physics and consciousness does come from quantum theory. Nevertheless, personally, I do not think that quantum theory is a full description of consciousness and mental experience, and certainly it isn't a full description of psychic experience. I certainly don't think an out-of-body experience is going to be explained by quantum theory. So I don't deny that quantum theory may be relevant to our final model of consciousness and psychic experiences, but I don't think it's the full explanation. I mean, after all, at the end of the day, nobody understands quantum theory anyway. So saying you're explaining mind instead of in terms of quantum theory is just replacing one mystery with another. My own perspective has always been that we need a deeper paradigm which underlies both quantum theory and mental experience, neither of which we understand. So that's where I'm coming from. I'm searching for that deeper paradigm. Now, what is that deeper paradigm? And my personal view is that this deeper paradigm has to have something to do with higher dimensions. I mean, in some sense, when I say higher dimensions, I mean that going beyond the traditional 3 dimensions of space and the 1 dimension of time, which ordinary classical physics deals with. Now, why do I say that? Well, one of the reasons I say that is that many mental and psychic experiences do involve some sort of space. I mean, you refer to out-of-body experiences. Well, what's clear about an out-of-body experience is it seems to take place in a space. And indeed, it seems rather like physical space. Now, there are reasons to think it actually isn't physical space, because when you're traveling around in this space, you don't normally seem to be detectable on things. But nevertheless, it certainly resembles physical space. But you don't have to go to something as dramatic as an out-of-body experience. An ordinary dream takes place in a space. I mean, I have lucid dreams, and sometimes I study the space when I'm having a lucid dream, and it's just as real as physical space. I mean, it seems just as real, and sometimes it's even hard to distinguish the difference. I mean, obviously there are differences between dream space and physical space, but they look the same. But then you've got other sorts of space which come up in psychical research. For example, there's a lot of interest in ghosts. Now, of course, lots of accounts of people having ghosts, experiencing ghosts. A skeptic will just say it's an illusion, an hallucination. Nevertheless, I think ghosts are more interesting than that, because it's clear that sometimes you can have veridical ghosts which more than one person sees at the same time, or you can have the traditional ghost which is seen by different people at different times in the same place. But the point about a ghost, again, the ghost seems to be in a space. And yet it doesn't seem to be quite the same as physical space, in the sense that normally you can't photograph this ghost. So it seems to be in a space, but it doesn't seem to be the same as physical space. And I could go on, and in some sense, almost all psychic experiences, I would claim, involve some form of space, including some of the more exalted mystical experiences, which you might not even want to call psychical. They sort of, you might say, will go beyond it. So my starting point was that many psychic experiences, and indeed many mental experiences, involve a space. And when I say mental experience, I really mean 3 types. I mean normal mental experience. I mean, if you like, paranormal mental experiences, like out-of-body experiences, and if you like, mystical experiences. They all involve a space, like a more complicated set of spaces, perhaps, but nevertheless a space. So then the question is, well, where does the link with physics comes? Well, to me, the link with physics comes because physics itself talks in terms of higher dimensional spaces. Obviously, we started with the normal Newtonian space, which is 3 dimensions. Then Einstein came along and taught us that time was a 4th dimension, so space is 4-dimensional. In other words, the reality which is required to describe the physical world is 4-dimensional space-time. But then later on, in the 1920s, 2 physicists called Kaluza and Klein started thinking, well, maybe just as Einstein has given a geometrical interpretation of of gravitation in terms of curved space-time, maybe we can unify electromagnetism and gravitation by introducing a fifth dimension. And they showed that by introducing a fifth dimension, you could have a geometrical unified picture of gravity and electromagnetism. The only point was this fifth dimension is wrapped up on a very small scale. It's wrapped up on a scale of what's called the Planck length, which is it's 10 to the minus 33 centimeters, which is really rather hard to envisage, but very, very small. Now, that was in the 1920s, and for many decades, most physicists rather lost interest in this. They got more interested in quantum theory and developments in quantum theory and things like that, even though it was realized it was a beautiful picture. But then in the 1980s, people started realizing that these extra dimensions could be useful in other ways, because by then we realized there were other forces. It wasn't just gravity and electromagnetism. We discovered there was the weak force and the strong force. And so it was realized that these other forces could also be described by invoking extra dimensions. And string theory came along in the 1980s, and this actually posited that there were actually 7 extra dimensions. So that in fact, the total dimensionality was originally 10 dimensions. So you would have the macroscopic dimensions, the 3 dimensions of space and the 1 dimension of time. And then there were the 6 internal dimensions, which in some sense were describing the other interactions in physics besides gravity and electromagnetism. That was in the mid-1980s. And that was the birth of superstring theory. But then it was realized that superstring theory came in many different forms. There were many different versions of superstring theory. And then in the mid-1990s, Ed Witten, a very brilliant physicist at Princeton, realized that you could have an amalgamation of all these theories, which is called M theory. And in M theory, you actually have 11 dimensions. So 1 extra dimension. And that's what certain group of physicists have been fascinated in ever since the mid-1990s. Now, the hope was that superstring theory and M theory would soon give us that final theory of physics, and hopefully quite soon. It turned out to be a much more complicated problem than that. We still haven't solved the equations of M theory completely. Indeed, it's very hard to make a direct link between M theory, which is at very high energies, and the laboratory type experiments which you can do at the Large Hadron Collider, for example. So some physicists react against that and say, well, this is mathematics. It's too far away from everyday physics. I mean, I tend to disagree with that, but it's certainly true. M theory is proving hard to test. But the point is that I'm trying to make is that it is respectable among physicists to think about higher dimensions. People might argue about whether it's mathematics or physics, but it's something which some of the brightest brains in the planet, have devoted their lives to thinking about. And in particular, there's another version of string theory, M theory, which I particularly like, which says, well, let's imagine, we can imagine that our world, our 4-dimensional world is like a brain, B-R-A-N-E, not the brain in your head, but a brain, like a surface. And we imagine this as being in a higher dimensional bulk, that's B-U-L-K. We can think of this as being a 5-dimensional bulk. And so in this picture, the physical world is like a 4-dimensional slice of a 5-dimensional higher dimensional space. Now, this is only one theory of coming out of the M theory. I mean, there are different variants, but this is a particular one that I particularly am fond of. Bear in mind, there are also these other extra dimensions, but the other extra dimensions are wrapped up on very small scales, whereas in this model, one of those dimensions is extended, and that's what's giving you the 5-dimensional bulk. But now, that's the picture that comes from, if you like, conventional physics. But now let's try and relate this to the higher dimensions required to explain consciousness. I was arguing earlier that the key feature about mental experience, be it normal, paranormal, or even spiritual, is that it seems to require a space. But it's not ordinary physical space. And in some ways, it seems to require a hierarchy of spaces. And in some sense, these seems to be a hierarchy of higher dimensional spaces. Well, then what can be more natural than to say, in some sense, maybe the higher dimensional spaces of physics are going to be able to accommodate the higher dimensional spaces to require to describe mental experience. Now, I have to warn you that this is not the mainstream physics view. In fact, most of my physics colleagues will probably be appalled at this suggestion. In some sense, M theorists already have trouble trying to convince their colleagues that they're working on some respectable branch of physics as opposed to very hypothetical mathematics. So the last thing they want to do is to be associated with phenomena which are, but at the very least, controversial. So I must not give the impression that this is a mainstream physics view. In fact, if most of my mainstream physicists see this interview, I'll probably get burnt as a heretic. So I'm normally quite discreet in what I say about this to a physics audience. Nevertheless, that's my hunch, put it this way. My hunch is that the higher dimensional spaces of physics will turn out to connect to the higher dimensions which are required to explain mental experience. And normally when talking to physicists, I try and talk about normal mental experiences rather than the paranormal ones, because that gets me into less trouble. Once you start talking about psychic phenomena, as I'm sure you're aware, and mystical experiences, you immediately get labeled crazy, or at least the heretic. But the point I try and make when I do talk to physicists is that even talking about normal mental phenomena, you've got to link that to physics somehow. There's a huge philosophical problem just relating perceptual space, phenomenal space to physical space, even before you get into the whole problem of paranormal phenomena. So that's my starting point. Now, once I've convinced physicists that they've got to accommodate normal mental phenomena, then of course I can more gingerly tread into the domain of paranormal and spiritual phenomena. But the main point about this is that once you accept that there is this higher dimensional space, it's what I call a universal structure. It's really important because it's saying you need an expanded view of science, an expanded view of physics even, that goes beyond the normal 4 dimensions of space-time, which is the conventional classical view of the physical world. Now, of course, that conventional view is what most scientists, most physicists adopt. Most people adopt the common sense of reality, view of reality, which is you've got 3 dimensions of space and 1 dimension of time. That's the materialistic view. But we already know that view is wrong. I mean, that was the view of the 19th century, which really died with the advent of Einstein's theory was classical, but quantum theory definitely went beyond that. So we know the old-fashioned materialistic view is dead anyway. And what this is saying is that if you have this higher dimensional view, if you're thinking beyond the brain to this higher dimensional bulk, you have to have a concept of reality, if you like, that goes beyond the normal materialistic reality. But then physics has told us that anyway. We already know from conventional physics that the old classical view is dead. Of course, it works very well within a certain context. It works when you're describing the everyday material world, which is what we experience in everyday life. But we know that picture does not describe the ultimate physical reality.
I want our viewers to know that we plan to have a lengthier conversation in which we'll go into really some fine detail regarding your explorations in hyperspace and how it might relate to consciousness. But I think it's useful for our viewers to also know you are one of the originators of the anthropic principle in cosmology, which also, especially in its strong form, has a lot to say about the nature of consciousness and the whole cosmos.
Yes, well, this goes back to 1979. Myself and Martin Rees, we wrote a review paper for Nature called the Anthropic Principle and the Structure of the Physical World. And the purpose of that was twofold. First of all, to show that the structure of the physical world and the various objects that exist in the physical world depend to a large extent on just a few dimensionless coupling constants. For example, all the things we see around us, like galaxies and stars and planets and people and black holes and things, their mass and length scale depend on, to a large extent, just on the what's called the electric fine structure constant and the gravitational fine structure constant, which are two dimensionless numbers which describe the strength of those forces. On subatomic scales, you have other constants, but most of the macroscopic world, which we study in astronomy, just depends upon those two dimensionless constants. But that was conventional physics, and we were able to show that most natural length scales depend upon these constants. So there's nothing controversial about that. But the second part of the paper was to show that there are unexplained coincidences involving the coupling constants, but also the masses of elementary particles and various fundamental constants that arise in cosmology, which seem to be necessary in order that we can be here as observers. In other words, in order that you can have stars and planets and galaxies and atoms and chemistry and things like that. Now, we weren't the originators of this idea. People have been writing about this for quite a few decades. The original anthropic argument probably goes back to someone called Bob Dickey in 1960. Nevertheless, we were able to put together all the anthropic constraints that various people had unearthed in one paper. So I think this paper had quite an impact because it was the first time Nature had published a sort of a big review bringing all these ideas together. I should say the word anthropic actually was coined by a colleague of mine called Brandon Carter. Now, I have to say that the reception at the time of that paper was rather split. Some people found it interesting, but on the other hand, there were quite a number of physicists who were very opposed to the concept of the anthropic principle. They argued that this was not proper science, that it was philosophy, because after all, you're speculating about counterfactual universes. You're trying to imagine what would the universe be like if the constants of nature were different. And indeed, some people thought it wasn't only philosophical as opposed to scientific. Some people thought it was actually theological, because of course, if you've got a fine-tuned universe, if you've got this tuning between the constants which can't be explained, some people thought, well, this must mean there's a tuner. Someone must have created the universe and the values of the constants so that we could be here observing it. And so, of course, this brought in hints of theology and this smelt of God, and that undoubtedly was a reason why many physicists were opposed, because physicists, by and large, do not want to invoke God. I mean, it's not that all physicists are atheists, but they like to keep God out of physics, just as they like to keep consciousness out of physics. And so at that time, there was quite a strong opposition to the idea of the anthropic principle. And even the word anthropic was unfortunate, because the word anthropic comes from the Greek word for man. And it suggests that the anthropic principle is something to do with human beings. It suggests the universe is created for us. But actually, that has never been my view. My view is that the anthropic principle, so-called, these coincidences are required in order to have interesting structures in life, in order to have stars and planets and galaxies and people and cells. But there's nothing specific about humans. So it was always a terrible phrase, the anthropic, and Brandon Carter himself admits it was not a very good choice of word. I prefer to call it the complexity principle. Nevertheless, we're stuck with this word now, the anthropic word. For many years, people wouldn't even utter the word anthropic. They would call the A word because it could get you into so much trouble in a physics seminar. So people would call it the A word. Now, this was when we wrote our paper in 1979. But the situation has changed now. Some 40 years later, the topic has almost become respectable, by which I mean that there are some very eminent physicists who now take the topic seriously. And I mean physicists like Steven Weinberg, my own supervisor, Stephen Hawking, people like Leonard Susskind. I mean, there are many, many eminent physicists, and Martin Rees, of course, my colleague, who was one of the originators of the idea. So there are many eminent physicists who now take the subject seriously. But the reason I think the subject is taken seriously is because we now have the concept of the multiverse. Now, the idea of the multiverse is that our universe might only be one of a huge number of other universes in which the constants could be different. Now, I should emphasize that the multiverse isn't just invoked to explain the anthropic tunings. The multiverse comes out of independent developments in both particle physics and cosmology. For example, it comes out of M theory. I was talking earlier about M theory. One of the predictions of M theory is that there could be what's called a string landscape. This is to say a set of solutions in which the vacuum can have many different states. See, it used to be hoped that string theory would give you a unique solution in which all the values of the constants will be unique. Unfortunately, that doesn't seem to be the case. It now looks as though they're going to be a huge number of solutions, maybe 10 to the 500 solutions, and each of these corresponds to a different vacuum state. And so one of the concepts of the multiverse comes from particle physics, from M theory, but also it's come out of development in cosmology. A very popular view of the early universe is that it went through what's called an inflationary phase at an early time. The inflationary phase means that at an early time, the universe was expanding exponentially fast because of the effects of the vacuum energy. And this can create lots of different bubbles. And in these different bubbles, the constants of nature could be different. And our visible universe is just part of one of those bubbles. So the concept of the multiverse has arisen in a number of different contexts, both from particle physics and cosmology. But once you've got a multiverse, then you've got the possibility that the constants are going to be different. So you then have a natural basis on which to have a selection effect, which says we have to be in one of the universes where life can arise so we can be observing it. So the anthropic principle just becomes a selection effect if you accept the multiverse. So for many physicists, the multiverse is what has legitimized anthropic reasoning, because you no longer need to invoke God, because if you have an infinite number of these universes, we necessarily are going to be in one which is appropriate for life. So it's rather like winning the lottery. You know, if you buy a lottery ticket and you win $1 billion, and you think, wow, this is a miracle, I must be special. But no, you realize that actually a billion other people bought lottery tickets, so someone's got to win. And it's rather like that with the multiverse. It looks amazing. It looks like a miracle we're in a universe where the constants are such that life can arise. But no, it may just reflect the fact there are millions of universes, so we just happen to be necessarily, we're going to be in one of the universes which support life. But I'll have to say, though, that not all physicists accept this. Some physicists don't like the multiverse either. because they say, well, we can't see these other universes, therefore it's not part of science proper. Generally, these are the same physicists who say the M theory isn't part of physics either. But so some people would even say that the multiverse is just as mystical as God. They're both equally mysterious. But nevertheless, I don't think that, and I think that a multiverse is much more respectable from a physicist's perspective than the idea of God. Now, I have to say, I've nothing against God. As you know, I'm interested in mystical experiences and the nature of God and things like that. So, from my perspective, the multiverse neither proves nor disproves God, because if God can create one universe, presumably he can create as many as he wants. In fact, if there's only one universe, I would say you then are in danger of having to invoke a creator, because if there's only one universe, you do have to explain these tunings. At least with a multiverse, you're not forced to invoke God, but that doesn't mean God doesn't exist. Now, but there's still the question, what is the multiverse? If you do believe in the anthropic principle, what is it selecting for? I've said it's not selecting for humans in particular, even though that's what the word anthropic means. But what is it selecting for? I mean, I mentioned my preference, which is the idea that in some sense it's selecting for complexity. In order that complexity can arise during the history of the Big Bang, you have to have these various tunings between the constants of physics. And that's the only reason you can have first galaxies and then stars and then planets and then people forming. Now, at the end of the day, we don't know what it's selecting for. Even if we accept that the anthropic principle is selecting for consciousness, and that was the original assumption. The original assumption is, how do I explain that there are observers, in the universe? Well, what is going to count as an observer? Is it only a human being? Or is it only a professor of mathematics? Or is it a human being? Or is it going to be a mouse? Or is it going to be an ant? Or is it going to be a computer? And the fact of the matter is we don't know. I mean, we don't know what the selection effect is. But I have to say my personal view is that it does have something to do with consciousness. I do think whatever the selection effect is, it does relate to the fact that there are observers, and that therefore relates to consciousness. I just don't think that it's related to ordinary human beings. I mean, I think it's far more general than that. I don't think it's related to human consciousness, which is why I don't think that it's the anthropic principle is a good term. But I do think it's related to consciousness. But I can't prove that. And then the question is, of course, if I'm going to talk about the multiverse, how am I going to relate that to this high-dimensional space, which I've already talked about for explaining mental experience? And oddly enough, in my professional writings about the multiverse, I never refer to psychic experiences, for example, because I keep those two areas very separate when I'm writing about the multiverse. If you read the book I edited, Universe or Multiverse, there's no reference to anything to do with any of my high-dimensional theories of mind or anything like that. Nevertheless, and of course, that doesn't mean privately I don't connect these two ideas, and I do think there is a connection between the multiverse and this high dimensional space. But I don't, I don't need to talk about that in arguing for the respectability of the multiverse. I suppose, though, the point I'm making is that a lot of the things I'm interested in life have got various degrees of hereticality. So, I've talked about the anthropic principle, which used to be taboo, and that used to be regarded as an heretical idea, but is now almost respectable in the sense that at least 50% of physicists seem prepared to talk about it. I've talked about the multiverse, which again is becoming more and more respectable. I've talked about consciousness, which again is more heretical than the anthropic principle, but that too in the last few decades has become respectable.
And you've also done work in black holes.
Well, of course, a lot of my professional life has been spent studying black holes. I'm a cosmologist, but I'm also interested in astrophysics, and I'm particularly interested in cosmology, in black holes. And I suppose the area in which I've spent most of my professional life working is the area of what are called primordial black holes. Now, these are black holes that form in the early universe. Now, I should say that the existence of black holes is predicted by Einstein's general theory of relativity way back in 1915. In fact, the first solution of Einstein's equations with a black hole was discovered by someone called Schwarzschild in 1916. So in theory, we knew about black holes all the way back in 1916. But even Einstein himself didn't take these solutions very seriously. And the solutions really only started being taken seriously in about the 1940s, when people realized that these objects could be the result of the collapse of stars. But then it wasn't until, I think in 1963, the term black hole was coined by John Wheeler. And then in the 70s, people started discovering actual astrophysical evidence for black holes. So by the 1970s, we had observations of this is from X-ray sources and things like this. You can't see a black hole, but you can see it gobbling up matter. So in the 1970s, we had actual evidence that black holes exist. But we had to wait something like 60 years, before we got that evidence. And now there is overwhelming evidence for black holes almost everywhere, not only as a result of stellar collapse, but we know there are huge black holes in the middle of galaxies. We know that there's a 4 billion solar mass black hole in the middle of the Milky Way, and there's a billion solar mass black hole powering quasars. And in fact, the biggest black hole is nearly 100 billion solar masses. So there are a huge range of black holes, which now people think really do exist. And the most dramatic evidence came only a few years ago when we discovered from LIGO we saw the gravitational waves from two merging black holes. So the evidence for black holes is now overwhelming. And I spend sometimes studying those more conventional black holes. But the black holes that really interested me were the black holes that might have formed in the early universe when the universe was very compressed. And I got interested in those because the person who first thought of these black holes was Stephen Hawking. He wrote his first paper on this subject in 1971, and I began my PhD with him in 1972. And so he got me to work on primordial black holes. And so the first paper I wrote was with Stephen on primordial black holes, and really I've been working on that subject ever since. The interesting thing about primordial black holes is they're much smaller than ordinary stellar black holes. A stellar black hole has got the size of a few kilometers, but the black holes that form in the universe can be much, much smaller. And in fact, what was interesting about these small black holes is that Stephen Hawking found they could have interesting quantum effects. Instead of being black, they emit particles. And this is the famous Hawking radiation, which I described earlier as one of the most important discoveries in theoretical physics of really perhaps the last century, last 50 years, say, because it beautifully reconciled quantum theory and relativity theory and thermodynamics. It unified them in a wonderful way. But the point is, this discovery is only relevant to primordial black holes. And therefore, that's what got people interested in primordial black holes. They're the only ones for which Hawking radiation could be important. Now, since then, I've spent 40 years studying primordial black holes, for most of those 40 years, it was a minority interest. I mean, people were interested in Hawking radiation, but most people didn't really think primordial black holes actually existed. Because it requires, you need the great compression of the Big Bang, but you also need the right conditions in order to make these black holes. You need to have fluctuations or phase transitions. So it wasn't clear that primordial black holes existed. It had been very tremendously interesting to think about them, because that had led Stephen to discover Hawking radiation. So it shows in physics it can sometimes be interesting to think about things even if they don't exist. But that didn't necessarily imply that primordial black holes actually formed. However, now, after 40 years, there's a great interest in primordial black holes. It's thought they could conceivably be the dark matter. It's thought that they could, even the black holes discovered by LIGO could conceivably be primordial black holes rather than ordinary stars, because they're bigger than the remnants of ordinary stellar collapse. It's sometimes suggested that the big black holes in the centers of galaxies could be of primordial origin. And so now cosmologists are becoming very interested in primordial black holes, because they have a huge range of masses, and they can be microscopic or macroscopic. And so for me, because I've worked on the subject for 40 years, this is very gratifying, because it means, after all, if primordial black holes don't exist, I've wasted a lot of my life. But if primordial black holes are shown to exist, then I'm lucky that I was one of the founders of the subject, working with Stephen Hawking. And so it's quite exciting. But it shows one of the ironies of doing research in physics. You often don't have to wait a long time before you know whether your ideas are right or not. That we had to wait 60 years before black holes were confirmed. We had to wait 100 years before gravitational waves were discovered. We had to wait 50 years before the Higgs boson was discovered. We might have to wait 30 years before the equations of M theory can be solved. So you have to be used to the idea in physics. So you have to wait a long time before theories are confirmed. And indeed, you can't necessarily be confident that your theory is going to be confirmed while you're alive. You might not even be known until after you've gone. And most of these ideas start off being controversial in physics. And, at first people think, oh, no, this can't be right. This is far too speculative. Black holes are far too speculative. Many of the early physicists didn't believe in black holes. Many didn't believe in gravitational waves. Some didn't even believe in the basic pictures of cosmology. And yet now we take these ideas for granted. So it is very gratifying to me that things that I've worked on, like the anthropic principle of the multiverse, are now becoming more mainstream. It's very gratifying to find that the ideas of primordial black holes are becoming more mainstream. So, of course, in the back of my mind, I have the hope that maybe some of my more speculative ideas relating higher dimensions to mental experience will also one day be mainstream. But I can't be sure of that. I mean, it could be that all these theories are crazy. Sometimes, although I've worked on these theories, these higher dimensional theories of mind, although this has been my passion, I suppose, for really 50 years, and part of me is convinced this has to be true. Another part of me is very skeptical, and I sometimes wake up in the middle of the night and think, oh my goodness, this could all be nonsense, because it's so far removed from everyday reality that you just wonder sometimes, is this right or wrong? And, so, I mean, I would never be so arrogant as to say these higher dimensional theories of mind are definitely correct. I mean, certainly most of my physics colleagues are going to reject these models at the outset, but then most of my physics colleagues aren't even going to believe the phenomena these models are trying to explain. Nevertheless, obviously, part of me hopes that this theory, or something along the lines of this theory, will turn out to be correct. So I'm not saying my particular hyperspatial model will be correct. I'm not saying that the actual M theory of physics will turn out to be correct. But I am betting that some higher dimensional model of physics will ultimately turn out to be correct, and that this is where mind will come. So I started off talking about the way in which physics can explain everything from the very small and the very large. I have this lovely image, my favorite image, of the cosmic Ouroboros, which is the snake which swallows its tail. And all the different scales of structure in the universe can be positioned around the snake, going from the smaller scale at the tail to the bigger scale at the head. The real question of physics, what happens where the head meets the tail? We've got relativity theory of the macroscopic domain. We've got quantum theory in the microscopic domain. Those two theories meet basically where the head meets the tail, which is at the Big Bang. That's where the very large meets the very small. And the great challenge in physics is, how do you reconcile relativity and quantum theory? Because these theories, they're tremendously successful in their own domains. Relativity describes the macroscopic domains, quantum theory describes the microscopic domains. The problem is these theories are incompatible. And so we're looking for a deeper marriage of these theories, which is going to reconcile the microscopic and the macroscopic, relativity and quantum theory. My belief is that that higher dimension, that final unification, that final marriage of microscopic and macroscopic is going to involve higher dimensions, and that is where mind and consciousness will come in. So when people say, how do I fit mind, how do I fit consciousness into the cosmic Ouroboros, which is the description of the triumph of physics, my answer is, it must, in some sense, consciousness is everywhere, but in some sense, explicitly, it must come in at the top where the head meets the tail. That is why I like to think the final theory that marries quantum theory and relativity theory is going in some sense to accommodate mind and consciousness. And that's because that's where the higher dimensions are coming in.
Well, that's a brilliant exposition, Bernard. And it seems to me that in cosmology and in physics, you've got theories that are waiting for confirmation. And in psychical research, we have 150 years of empirical data that's waiting for a theory.
Absolutely. And I think that's why psychical research is still not regarded as a respectable branch of science. Personally, I would say the empirical evidence for psychic phenomena, or at least some psychic phenomena, I would say is overwhelming. I mean, obviously, you have to specify which phenomena you're talking about. But what's important about these phenomena is that they seem to involve an direct interaction between consciousness and the physical world, if you believe in psi. And that's why I think you need an expansion of physics. But as you've alluded to, the problem is we have all this evidence, both from laboratory work and from everyday life, which has built up over the Society for Psychical Research was founded 137 years ago or whatever. But what is lacking is a theory. We need a theory of psi, because otherwise it will not be taken as a branch of mainstream science. And not only do you need a theory, I would say, which is on the level of a physical theory. I mean, there are already psychological theories of psi, in terms of the type of what types of people are good at psi, sheeps, goats, and things like that. But I'm saying you need a deeper theory. You need a theory on a level of physics, because psi seems to involve a direct interaction between consciousness and the physical world. Now, that's a problem, because most physicists don't believe in psi, and most psychical researchers, most parapsychologists, aren't very interested in physics. I mean, most of them come from a background in psychology, and they're not so interested in physics. Nevertheless, I'm biased because I am a physicist, and there are, a relatively small number of physicists interested in psychical research. And because I feel that physics is in some sense the most basic of the sciences, the queen of the sciences, my view is you have to have a theory of an extension of physics which will accommodate psi. Until you've got that, it will not be part of mainstream science. And that's why I've been struggling all these years to try and have a theory of physics. Now, I've already indicated that I believe the best hope lies in a higher dimensional theory for accommodating mental and psychic phenomena. But even if that turns out to be wrong, even if the hyperspatial models turn out to be garbage, I would still claim you need some extension of physics. And until you have that extension of physics, the subject will not be, psychical research will not be regarded as a respectable science. That's my view.
Bernard Carr, this has been a really thrilling discussion. I appreciate so much the decades of thought that you have put into these ideas, and I am so pleased to let our viewers know that you and I plan to follow up and have more in-depth discussions about each of these areas, hyperspace, the anthropic principle, black holes, your years of working with Stephen Hawking, and of course, especially psychical research. Thank you so much for being with me.
Thank you very much too, Jeff, for giving me the chance to talk about these three areas, because actually in most of my life, these areas are rather disjoint, and I appreciate the opportunity to try and link them, and your interview has given me that opportunity, so I'm very grateful for that, and I look forward to coming back.
Thank you again, and for those of you viewing, thank you for being with us. For early access to our videos and live stream events, sign up for our free weekly newsletter at newthinkingaloud.org.
Book 4 in the New Thinking Aloud dialogue series is Charles T. Tart, 70 Years of Exploring Consciousness and Parapsychology, now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.